What do you think is the largest 3D printed part in the world? People are 3D printing houses, people are 3D printing horse trailers, people have even 3D printed boats that float. But actually, the largest 3D printed object is being sent to space. It's 32 meters high, it's made of space-age alloys, and it can carry 1,200 kilograms of cargo into low Earth orbit. It's the Terran 1 from Relativity Space. So the Terran 1 is an absolutely fantastic piece of 3D printing engineering. 85% of it by mass is 3D printed, which is completely different from anything that has ever been done before. Relativity Space is taking advantage of every aspect of 3D printing in order to create a rocket that is totally new and different from anything that has ever come before it. Now, it's really not that new for 3D printing to be used in aerospace. It has been used for almost decades now in order to create prototypes, and in the last 20 years to create final use parts in airplanes and rockets. 3D printing allows you to lightweight a part exceptionally in ways that traditional manufacturing just can't achieve, but it also allows you to create design freedom that was never possible before around the consolidation of parts and all kinds of other capabilities that are highly utilized by aerospace and yet for some reason not really used by anybody else. But it is fantastic what the team at Relativity Space has done in order to take advantage of every part of 3D printing. First of all, they built their own 3D printers. The Stargate 3D printers are in their 4th generation right now, and Relativity has created a system that allows them to basically use a robot with a welder on the end to lay down beads of metal in a slow pattern in order to slowly grow a machine. It could be the tank of the rocket, it could be the rocket engine itself. But because they do this, they get all of the advantages of 3D printing. One of the biggest advantages is right within their engines right off the bat. Rocket engines are exceptionally complex. Historically, they have needed to be put together by hand with men soldering tubes along the nozzle in order to cool it, which has been phenomenally labor intensive and phenomenally expensive and phenomenally unsafe, because if there is any error made anywhere within that, then it could blow up the rocket. But Relativity is getting around this because they're able to take all of that complexity and all of those parts and pieces and make them as a single part. Since 3D printing is able to create impossible geometries compared to regular manufacturing, they're able to inlay tubes and combine parts and pieces that would otherwise be impossible to create as a single piece. So they are able to create a much simpler base component with far fewer points of failure, so a rocket engine reliability actually goes up. Secondly, since it's 3D printed, all they're dealing with is a digital file. So as time goes by, they can update the design of each one of their rockets as they're being made, so they're not tied into any sort of tooling or any sort of legacy rules. If they have a particular type of satellite that they need to mount into the upper fairing of the rocket, they can just change the design of that fairing so that the mounting holes are in different places, and now they can mount that particular satellite into the fairing, heavily improving the customer experience for folks who need to mount something inside of a rocket. Traditionally, this is done through all types of complicated fixturing and other sorts of processes that are no longer necessary because the rocket is grown to fit this precise payload that it is being used to launch. And this is a huge advantage for Relativity Space. But there are no doubt a large number of engineering challenges that Relativity has had to overcome in order to actually hit this and create a final finished product that is going to space. The first things that are most interesting that they have done is they have changed the geometry of how their rockets are made. If you look at the partial segments that they have inside of their factory, they are actually using organic type of designs in order to improve the rigidity of their rocket. They're actually creating these sort of scalloped and wavy shapes at the dome ends of the rockets in order to take more force and more pressure, inspired by things like oysters and all types of other organic methods. These were not manufacturable with traditional methods, but 3D printing allows it, and it actually assists the process and is more reliable. But then, since Relativity has also created their own machines, they're able to dive very deep into how the process works. They are dynamically changing how the printers print throughout the print as they observe it to make sure that there are no defects throughout the entire rocket. And since they're basically observing this welding bead going down, they know if there is a potential defect anywhere and are able to track it down and either plug it, fix it, or redo it if they need to. But they know this rocket over every single inch because they literally have watched every single inch be put down. Now, that is a very difficult thing to do. To create hardware and software that prints a rocket is not a simple matter. And then on top of that, they have to build a rocket that is a compelling product. But this is probably what is most fascinating about Relativity Space. If they had created those 3D printers and said these can print print water tanks and these can print rocket nozzles. They probably could have sold those machines, but they would have been following the exact same model as every other company in the 3D printing industry. And it is amazing to see that they didn't build printers for printers' sake and then built the machines and said, somebody figure out what to do with these. They said, we need to build a rocket. 3D printing is the right way to build a rocket. We're gonna build the printers that can do it. They built the printers in order to make the product. They didn't build the printers and expect someone else to make the product, which is a terrible business model and one that the industry as a whole needs to get away from. They wanted to make a final finished product, a product that was uncomparable to anybody else. 3D printing enabled that. The 3D printing machines are a side effect of the product that they wanted to create. They focused on what the end goal was. They focused on the customer, and 3D printing fell out from that. That is an example to take to the bank. It's fantastically hard, and Relativity has had to build two companies in one, a rocket company and a 3D printing company, in order to achieve this. But they are achieving it. And the Terran 1, the first prototype of it, is attempting a launch on March 8th. And we can only wish them the best and hope that the largest 3D printed part in the world makes it into space all right. This video is sponsored by Angled.io. Angled.io is using mass production 3D printing to allow designers to create products that could have never existed before. Angled takes care of the production and fulfillment of products, and designers receive royalties from all of the designs that are sold on the platform. In order to find out more or to purchase a product that you will not find anywhere else, go ahead and visit Angled.io.